All right, so after 18, I had to go back and look at my data again. 23 and 28. And then I'm going to put in the values for my grass height, which was in centimeters. So we have 1.2, 4.8, 6.2, 10.9, 12.4, and 15.2. And you'll notice that some green dots started to appear on my graph. So you can see one here, we can see one here, but we can't see them all. So we're going to zoom out, and now I can see all of them. And now I've plotted my data, and if I were to play connect the dots, la, 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 like Elmo would on Sesame Street, generally speaking, we have a straight line. Now, it's not perfect, but it is definitely a line. It's not a smiley face, it's not a U, it's not an S, it is a line. So since I know it is linear, then that means I can type in my regression equation to determine the equation of the line of best fit. Now, for depending on the shape of your line, you'll use a different formula, but the basics are the same. We're going to type Y1. We leave our data chart, don't remove that. And that little one tells us that little one doesn't tell us, it tells the calculator to pull the data from our table. And we're not going to use an equal sign. Instead, we're going to put in the tilde, and then we're going to put in the standard or the slope intercept form of a line, which is y equals mx plus b. So I have my y, and then I'm going to do my mx plus b. So I have m, and I'm going to say x, but I wanted to pull my x data from the chart, so I have to say x1 plus b. Now you might also see this as an a instead of an m, but I like to use m and b because it's what we're used to. Now I'm going to erase my little connect the dots line here for you. And you can see that Desmos has drawn a line, and it's pretty close to the green dots. So I am now able to write my equation of best fit. And I use the numbers that you see right here on your screen for M and B. So if I were to write my equation, it would be y equals 0.56, because I'm going to round, x minus, because notice the b is a negative, 0.19. And I'm rounding. And do you notice how the black line appeared right over the top of the red one? And it's a little off, and you can see a shadow of the red here every so often. And that's because we are estimating. That's why the questions asked you to estimate the equation of the line of best fit, because we only have a few points of data. We don't have every point on the line. And that's it. All done. Now, the last step is going to ask us to predict the value of y when given an x value. Now, in this example, it's telling us to predict the height of the grass on April 30th. So that means predict what is y going to equal when x is 30. So I'm going to start right here on my x-axis, and I'm going to find 30. Now, you may have to zoom out on your graph to find it, but there's 30. And then I'm going to follow all the way up this line until I get to the graph. And then I'm going to click and hold on the graph, and you'll notice as I move, my numbers change. So I want to get to exactly 30.0. And I don't have a real steady hand, y'all. There it is, 30. So that means the prediction of the height of the grass will be 16.61. So that means that the point 30 is our x value, and 16.61 is going to go inside, is going to be our answer for the y value. So you just go put that back in bus. Good luck.